Number one, solve the quadratic linear system below algebraically. So I've got a circle and a linear function here, and I want to know where do they intersect. So let me isolate y in the linear equation. So maybe the first thing you notice was I can divide everything by 2 to get 2x minus y equals 4. That's always something that's helpful to do to simplify linear expressions. Subtract 2x, negative y equals negative 2x plus 4. So y equals 2x minus 4. So now that I know what y equals, I can pick that up and substitute that in for y in the equation of the circle and get x plus 3 squared plus y squared equals 20. So now I just have to square each of these binomials here and make a table. Make a table to square these binomials. X squared plus 6x plus 9 plus square the first, 2 times their product, square the last, equals 20. So cleaning up the left-hand side here, I've got 5x squareds, negative 10x plus 25 equals 20. Well, it's a quadratic equation, so I've got to set it equal to 0, which leaves me with 5x squared minus 10x plus 5 equals 0. I can definitely take out a GCF here of 5 to simplify this expression greatly. Well, I've got a trinomial here to factor by saying self, what multiplies to 1 that adds to negative 2. That'd be x minus 1 and x minus 1. The 5 really doesn't matter because the only x value that I get is x equals 1. So I know x equals 1 in the point of intersection between the circle and this line. When I plug in 1 to my linear equation here, 2 times 1 minus 4 gives me negative 2. So this line is tangent to the circle at the point 1 comma negative 2. Find the solutions to the system of equations in simplest radical form. So I've got a circle and a line, and I know y equals 7x, so I'm going to pick up that 7x and plug that in for y. You get x squared plus 7x squared quantity equals 10. Well, x squared plus 49x squared equals 10. So 50x squared equals 10. I can use inverse operations here and divide x squared equals 1/5. So when I take the square root, I have 2 possible solutions, plus or minus the square root of 1/5. So let me make my ordered pairs here. I want to know what are the points of intersections. That's what we're doing when we find the solution to a system of equations. I've got the square root of 1/5 and negative square roots of 1/5. Well, if that's my x value and I plug those in for x, that gives me 7 square roots of 1/5. And if I plug in negative square roots of 1/5 for x, multiply it by 7, gives me negative 7 square roots of 1/5. So we get these irrational numbers here as solutions to our system of equations.